Okay, so welcome to Module 4, the slideshow lecture on offset lithography printing essentials. We're going to cover this list of topics here on the on the left, and these are concepts that you'll want to know as a designer that happen in pre-press and with the printing. Mainly for offset lithography. Many of them will happen for the various types of printing, gravure, flexography. You don't really come across much of this with letterpress printing and so on, but these are some basic concepts to learn for print production. First off, we'll start with the CMYK color builds. And on the screen here we have the two color models. We have a CMYK model and the RGB model. So CMYK is what we all learned in kindergarten. You know, yellow and blue makes green, yellow and red makes orange, and so on. How we mix the paint together to get the different colors. Well, in printing we have cyan, which is a light blue, magenta, which is a pink, and yellow, which is actually quite a pale yellow. And so in order to get a pure red, you generally mix 100% yellow with 100% magenta, and that gives you your red. To get a rich blue, you would mix 100% cyan with 100% magenta to get a rich blue. It might be a little bit on the reddish side, but close enough. When you mix all the colors together, you get a brown or close to black. But we add the color black with the CM and Y there to make it a 4-color printing. What's kind of cool is that the primary colors for light are the opposite. So that when you take your 3 primary colors for light are red, green, and blue light. So this is anything that's emitting light. TV screens, your phones, tablets, monitors, scanners, projectors, all the things that emit light use the light primary colors. When you mix red and green light, you get a yellow light, believe it or not. Sometimes it's hard to wrap your head around, but when you mix a blue and green light, you get a cyan. Red and blue light makes a magenta, and when you mix all the light together, you get white. So it's kind of neat how it's the opposite. Something interesting in the physics there between light and pigment primary colors. So the next item on our list is a spot color. To understand what spot color is a pre-mixed ink to a specific hue. So the ink is already mixed, and it only takes that one ink to make that special green or that special blue. Now, companies will have their own spot colors for their logos, and that way they're sure that their logo always gets printed with the right color. And some very large companies even make their own spot color and name it after themselves. So, like when I worked with the Pepsi logo, the blue is actually called Pepsi Blue, and it's their own special mix of ink to get that blue. So in the next couple screens, though, we'll look at the differences between spot color printing and CMYK printing and what that means. CMYK printing is called 4-color printing, or also full color, as in that's how you get full color photographs. So let's look at 4-color process printing. It has a lot of different names. 4-color printing, CMYK printing. The CMYK inks, cyan, magenta, yellow, and black, which is the K because it's known as key color, meaning that they would align the other colors to the black. It's the key color that gets laid down on the paper. All of those are called process colors, so it's also called process printing. So there's a lot of different terms that describe the same thing. Anyways, it's basically breaking down the 3 primary colors plus black to create a mixture that can create thousands and millions of different colors. So if you're trying to reproduce full color photographs, you want to use process printing. It's going to be very difficult to use spot colors for that, unless your 4 spot colors are cyan, magenta, yellow, and black. Essentially, that's what that is. Cyan, magenta, yellow, and black could be considered a spot color, but they're the basic colors set to a standard hue, and that's what's used for process printing. So in this example here, they're recreating this logo to get that specific color with the shading and the gradient in there inside this little reflection on the L and so on. You can do that with process printing. It'd be much more difficult to do this with spot color. And here's a close-up view of how the ink is laid down. And we'll look at that more in the future slides in this lecture here. So, the advantages for spot color or for process printing is that it's the best way to get realistic photographs. And if you're going to use more than three spot colors, Pantone colors, you're better off just going with process printing because it'll cost the same or be even less, and you'll get better results. The disadvantages is that when you're trying to recreate a color over a long print run or over, say, a month later, you're trying to print the same thing a month later, the ink, since it's a mixture of inks, if that balance is off just a little bit, it becomes very noticeable. And so that navy blue might be a different navy blue when it's printed a month later. Spot color printing. Here we have an example of that same logo, but you can see it's just got the 2 colors here. We've got the red and the black, and it creates a simpler logo. Kind of striking though still, but it's much more economical because it only uses 2 inks and it can run on a smaller press that doesn't need as much ink. So, and like I said, the advantage is that spot color, the color is consistent. Even if it's printed a month or a year later, that Pantone 186 red will always be that same color. However, spot colors you can't really print on digital devices or laser printers and so on. You can get specific metallic and fluorescent colors in spot colors, which are only available as spot color. So that's an advantage over CMYK. Okay, bleed. During one of our class sessions, you all had mentioned that you're familiar with bleed, but bleed is essentially when images are supposed to go to the edge of a page, like it looks like in this book here. That way, when it goes through the production process, if that cut is not perfect, which many times it's not, there would be no chance of a little white line showing where the cut missed the very edge. So bleed is just a precaution to avoid seeing these white lines around the edges of your pages. The next 2 terms, overprint and knockout, kind of go together. They're opposite of each other. So overprinting is when a color is designed to print directly on top of another color intended to mix, and a knockout is where the color knocks out the color behind it. So you can see in this diagram here, we have a cyan A being printed on a magenta background, and with overprinting on, that cyan A will blend with the magenta to create a different color. Where here, with it knocked out, the A knocks out the magenta so that cyan stays as the magenta. I'm sorry, the A stays as the cyan. Some problems with knocking out is that if the registration is off, and we'll talk about registration in the next slide here, then you can have little white lines showing. So it's kind of nice to have overprinting when you're printing with black on top of a color, especially if you're printing with very small text or thin lines. However, here overprinting is an issue if you have a large black area like this A is very large and it's on top of half of this cyan rectangle, to where the cyan and black mix here, and if you look very closely, there is a darker, the bottom half of this A is darker, and you can see a little line right there to where that black is a little bit lighter. And that's because these process inks, the cyan, magenta, yellow, and black, they are actually a little bit transparent, and that allows them to help them blend together when they're combined, the halftone dots, to blend the colors together. Anyways, there's your overprint and knockout. Registration is when correctly aligning the printing inks together. So you're printing cyan, magenta, yellow, and black down, and they need to match up perfectly. So these little targets here are all around the outside edge of a print sheet, and that's what the press operator uses to measure and make sure all the inks are lined up correctly. So he'll look through a magnifying glass called a loop and be able to see very closely how he needs to adjust his plates. Here's an actual, you've probably seen this in some old newspapers or newspaper advertisements. They have really poor registration many times where these colors are not lining up. So when registration is off, there's a method they use in prepress called trapping. And trapping is a way to manipulate the colors to eliminate those unwanted gaps. So essentially what happens is they'll spread or choke the color that are adjacent to each other so that they very slightly overlap. They have an overlap of 1 point. So if you think of like a 8-point type and you divide that down to 1 point, they'll actually overlap of a choke of 1 point, or even smaller. They get down to half a point trapping. So it's not noticeable. This is exaggerated right here, this A with that darker blue around there. That's exaggerated to show you what trapping is doing. But you don't really notice that with your eyes. So when you see that, then it's an error. If you do notice it, it is an error of too much trap. If you don't have a trap, you're going to get these white gaps like that when the registration is off, or like this section here where the black is knocking out the magenta. So it's better to overprint that black there, the small text. I'm going to pause it here and go to the next movie to continue the lecture.